Welcome to This Explainer. Today, we're jumping right into some Grade 7 information technology basics, and in the process, we're going to become tech detectives. If you've ever stared in total frustration at a broken computer, just wondering what on earth went wrong, well, this is exactly where you need to be. We're going to learn how to stop guessing and start actually solving.
Picture this. You're right in the middle of a super intense multiplayer game. You're about to make that epic winning move, and suddenly, bam, the screen freezes. Your character is totally stuck in place, the app unexpectedly closes, and you're just staring at a cold, gray box that says connection lost. Meanwhile, your laptop fan sounds like a jet engine getting ready for takeoff. Why did this happen? What actually broke? To figure it out, we need to treat this like a real investigation.
To solve this digital mystery, we need a game plan. Here is our detective's case briefing. We'll check out the crime scene, look at the suspects, do an interrogation, deliver the verdict, and finally, look at the next case. Let's get right to it.
Section 1. The crime scene.
A good tech detective always starts by actually observing what happened. We can't just say, it broke. Look closely at the clues here. The game started lagging heavily before the character completely froze. The app closed itself with a very specific connection lost error, and man, that laptop fan was running loud. These aren't just random details, right? They're crucial pieces of evidence that'll lead us straight to the culprit.
Moving on to Section 2. The suspects.
Think of your computer not as one magic box, but as a team of 4 distinct players. We've got hardware, software, data, and network. They each make up exactly 25% of this system pie. And here's why this matters. If literally even one of these slices fails, the whole system goes down. Let's look a little closer at each suspect. First, let's break down the physical versus the digital. Hardware is the stuff you can physically touch, right? The keyboard, the screen, that super loud fan trying to cool down the processor. Software, on the other hand, is the invisible code. It's the game app itself or your operating system. You can't touch it. So if the laptop is physically hot, that's a hardware symptom. But if an app just suddenly closes on you, that is a software symptom.
Then we have to separate your specific data from the broader network. Data is your specific information. Your personal game save, your custom avatar, your player stats. But the network, that's the communication pathway. It's how that data actually travels and connects different systems together, like the internet sending your avatar's position to the game server.
Section 3. Interrogation.
Okay, it's time to clear up some major tech myths. A lot of folks think Wi-Fi and the internet are the exact same thing. No way. Wi-Fi is literally just your local wireless bridge to your router. You could have perfect full Wi-Fi bars, but if your internet service provider is down, you're still not getting online. Your local bridge is perfectly fine, but the road out of town is totally closed.
Here's another one. Thinking your web browser is the internet. We all click Chrome or Safari and think, I'm opening the internet. But actually, a browser is just a piece of software. It's a viewing tool used to explore the network. If your browser crashes, it definitely doesn't mean the whole internet went down. It just means that one software suspect failed.
Section 4. The verdict.
All right, time to bust out the ultimate detective's notebook, the CER framework. That stands for claim, evidence, and reasoning. In IT, you can't just guess that something is broken. You have to logically prove exactly why it failed and where the breakdown happened. This framework is exactly how professionals diagnose and explain tech issues.
Here's how it works. Step 1 is your claim. What specific component is broken? Step 2 is evidence. What are your direct, undeniable observations from the scene? And step 3 is reasoning. Why does that evidence logically prove your claim is correct? Breaking it down like this transforms random guessing into actual professional IT analysis.
So let's apply this to our game crash. What's our evidence? Well, the laptop was physically hot, sure, but the screen and keyboard worked fine. Other apps were running perfectly in the background. But the real smoking gun? The game threw a very specific connection lost error right before it abruptly closed. Based on those clues, here is our claim. A network failure caused the software to crash. That's a bold, clear claim. We aren't blaming the hardware, even though the laptop was hot. And we aren't saying the game software itself is defective. We are pointing right at the network. But, a claim is nothing without backing it up.
And here is our reasoning. Because only one app crashed, and it gave us that specific connection lost error. While everything else locally kept working perfectly, the evidence clearly points to a break in the network pathway. It wasn't a hardware or data failure. The hardware was just working hard to process the game, but the network completely dropped, which forced the software to crash. Boom! Case closed.
And finally, Section 5, the next case. You solved your first major mystery, but a tech detective's work is never really done, right? I'll leave you with this, to test your new skills. Imagine you're trying to save a massive school project, but a pop-up says, disk full, and the save fails. Ask yourself, is this a hardware, software, data, or network issue? And most importantly, what is your evidence? Think about how you'd use the CER framework for this brand new case. Thanks so much for joining me on this explainer, and happy sleuthing on your next investigation.